Exercise 21.5, question 8. So in this question, there is a boy firing stones from a catapult at a target which is on a wall. And we're given that the wall is 5 meters away and the height of the wall is 3. And we also know that he is firing from a height of 1. And we're given that the target is on the top of the wall and that he hits the target. So the projectile is going to go like that and hit it on the way down, or it might just hit it on the way up. So, and the other information we are given that the initial speed is 7 root 2. And we can see there are two possible values of theta here. There's this theta here, the larger theta, where it goes up and hits the target on the way down. Or there is the smaller value of theta, we'll call that theta 2, in which it just hits it on the way up. And we're asked to find a quadratic equation in tan theta that is satisfied here. Well, let's take this as the origin and let's think about what we know. We know that at the time that it hits the target, the displacement is 5 horizontally and 3 vertically. But we are not starting at the origin, so we need to account for the initial displacement being 0, 1. We know the acceleration is 0 minus g because the only force acting is gravity, and we know that the initial velocity, u, is 7 root 2 cos theta, 7 root 2 sine theta. And if we put this information into r equals r0 plus ut plus a half a t squared, we get 5, 3 equals 0, 1 plus 7 root 2 cos theta, 7 root 2 sine theta, multiplied by t, plus a half of 0 minus g t squared. And reading off the horizontal and vertical components, we get 5 equals 7 root 2 t cos theta. And from the vertical component, we get 3 equals 1 plus 7 root 2 t sine theta minus g over 2 t squared. Well, we want to eliminate t, so if we take this first one and we rearrange that for t, we get t equals 5 over 7 root 2 cos theta. And now we can substitute this into the second one. So 3 minus 3 subtract 1, so we get 2 equals 7 root 2 multiplied by t, so times 5 over 7 root 2 cos theta times sine theta minus g over 2, 5 over 7 root 2 cos theta, all squared. Well, doing a little bit of simplifying on this, we get 2 equals, well, the 7 root 2's both just cancel. And we get sine theta over cos theta, so we get 5 tan theta minus g over 2, lots of 5 squared is 25, and then 7 root 2 squared is 49 times 2, which is 98, and then 1 over cos squared theta. But notice that 1 over cos squared theta is sec squared theta. So we can actually just write in here sec squared theta. Sec squared theta. And a bit of further simplification, we get 2 equals 5 tan theta. And if we use g as approximately 9.8, we get minus 9.8 over 2 times 25 over 98. And then we know sec theta is 1 plus tan squared theta. Well, notice that 9.8 divided by 98 is a tenth. So 2 equals 5 tan theta minus 25 over 2 times 10, so 21 plus tan squared theta. But actually, we can simplify 25 over 20, 5's go 5 and 5's go 4, so this is just 5 over 4. While multiplying through by 4, we get 8 equals 20 tan theta minus, and then expanding out this bracket, 5 minus 5 tan squared theta. And that is just the quadratic equation we want once we rearrange it. So adding 5 tan squared theta to both sides, adding 5 to both sides, and subtracting 20 tan theta, we get the quadratic equation in tan theta that we were asked for. Part 2 asks you to find the two values of theta. Well, that's absolutely fine, and I'm not going to do that because all you need to do is solve this quadratic equation for theta. That will give you two possible values of tan theta. We know that theta is acute, so we can find the two principal values of tan inverse to find the angles.